Now we are looking at modelling with differentiation. The area of an expanding circle, radius r centimetres, is given by a equals pi r squared. So the area of the circle is equal to pi r squared. We need to find the rate of change. Whenever we see rate of change, we need to think differentiation. So the rate of change of the area with respect to the radius, so of the area of A with respect to the radius r. So that's dA dr at the instant when r equals 5. So A is pi r squared. We want dA dr. To find the gradient function, the rate of change of A is the gradient function. We times by the power and take one off the power. So times by 2. Remember pi is just a number. So 2 times pi becomes 2 pi. And take one off the power. That becomes 2 pi r. So dA dr is 2 pi r. When r equals 5, the rate of change of A with respect to r is 2 pi times 5, which is 10 pi. Here's one for you to try. Give it a go. So the volume of an expanding cube is v equals x cubed, where x is the length. Find the rate of change of the volume with respect to the length. So the volume was v, the length was x, so it's dv dx that we want. dv dx. And to find dv dx, we differentiate. So times by the power, take one off the power, we get 3x squared. So when x is equal to 5, dv dx is 3 times 5 squared, 3/25, that is 75. Here's another question. A cylinder has radius r, height h. The total surface area of the cylinder is 80 pi centimeters squared. Show that the volume of the cylinder is v equals 40 pi r minus pi r cubed. So we need to use the surface area and the volume formulas. So it's a cylinder. So the surface area. So we've got 2 circles at the top and the bottom. So 2 circles. Both of those are pi r squared. So we've got 2 pi r squareds plus its h tool, and this curved bit is a rectangle. It's 2 pi r long, so the circumference of a circle, and h tool. So it's 2 pi r h. And the volume is pi r squared, area of the cross section times the height, which is h. So we want to get the volume of the cylinder without a h in it. So we have to eliminate h using the surface area formula. The surface area is 80 pi. So 80 pi is 2 pi r squared plus 2 pi r h. We can divide through by pi. Then we want to get h by itself. So take away, let's divide through by 2 as well. Now let's get h by itself. So take away r squared. So 40 minus r squared is r h. And then divide by r. So we'll have 40 over r minus r equals h. Then we can substitute this in for h in our volume. So pi r squared times 40 over r minus r, and expand the bracket. So we get 40 pi r. It would be squared, but then it's divided by r, so just 1r, minus pi r cubed. Given that r varies, find the maximum volume of the cylinder. So the maximum is where our gradient function equals 0. So it's going to be where dv dr equals 0. So let's work out dv dr. We've got v dv dr. So we're differentiating with respect to r. So times by the power, take one off the power. That's just 40 pi. R is where x usually is. Apart from that, it's just the same. We're just differentiating. Times by the power, take one off the power. Then minus 3 pi r squared. What does r have to be to make it 0? So it's a maximum when dv dr equals 0. So 40 pi minus 3 pi r squared equals 0. Divide through by pi. So we've got 40 equals 3r squared. 40 over 3 equals r squared. So r is the square root of 40 over 3. It has to be the positive square root because we can't have a negative radius. So find the maximum volume of the cylinder. So we don't want r, we want v. So square root of 40 over 3 is r. V is 40 pi r minus pi r cubed. So 40 pi times answer minus pi times answer cubed. So that's 306. So V is 306 to 3 significant figures. And that is in centimeters cubed. Justify that the value of V is a maximum. So we can do that by finding the second differential. So d squared v over dr squared, the second differential. So 40 pi, that's just a number, that's going to disappear. And we times by the power, so negative 6 pi r, take one off the power. So that is our second derivative. When r is 40 over square root 40 over 3. We're going to get a negative answer. So negative 6 pi times the square root of 40 over 3. So we get negative 68.8. So it's negative. And if the second derivative is negative, that means we've got a maximum point. And that's because at a maximum point, the gradient is going from positive to negative. It's going down. So the gradient of the gradient is negative. So if it's negative, we've got a maximum. Here's one for you to try. Pause the video, give it a go. We have a cuboid with a square base. So it's a base of x by x and a height of y. The total surface area of the cuboid is 200 centimeters squared. So the volume of the cuboid can be given as this. So we know the volume is going to be x squared y. And the surface area, so we're going to have 2 x squareds, the top and the bottom, and then all 4 of the other sides will be x y's. and the surface area is 200. And we can half everything. That's half everything. So 100 equals x squared plus 2xy. We're going to eliminate y. So let's get y by itself. So 100 minus x squared over 2x is equal to y. Then we can substitute that in to our volume. So we've got x squared times 100 minus x squared over 2x. Expand the brackets. So 100 x squared over 2x minus x to the power of 4 over 2x. And simplifying gives us 50x minus x cubed over 2. That's what we wanted. Given that x varies, find the maximum. So we want dv dx. So we're just differentiating. 50x becomes 50. Negative x cubed over 2. That's the same as negative a half x cubed. So times by the power. Negative 3 over 2. Take 1 off the power. 3 minus 1 is 2. We want to find the maximum. That's a turning point. That's where the gradient is equal to 0. So 50 minus 3 over 2 x squared equals 0. So 50 equals 3 over 2 x squared times by 2, divide by 3. So x is the square root of 100 over 3. And we can give that to 3 significant figures. We don't want to though, because we want the volume, not the length. So substitute that into v. So I'm just going to store it as a, and v is 50x minus x cubed over 2. So 50a minus a cubed over 2, 192. Centimeters cubed. Justify that we've got a maximum. So the second derivative. So we've got the first derivative here. The second derivative is times by the power, take 1 off the power, the 50 disappears. So we are going to have negative 3x. And when x is the square root of 100 over 3, so negative 3 times a is negative 10 root 3. So it's negative, therefore it is a maximum. So the second derivative is negative, therefore it's a maximum point.